I mean by that? Okay, you can have a case where you have got letters. This case here involves, in most cases, letters. Okay, in most cases it involves what? Letters. Now, in a letter, or rather in a word, like cumulative. Alright, if you have got a letter which has got identical, so you have got a word with identical letters, okay? If you want to determine the total number of arrangements, okay, or the total number of words you can form, in that case, you need to count the total of all the letters, then you divide by the product, okay, by the product of the repeated or rather identical letters in the word. Okay, please, generally we don't use the word repeated in a situation like this. We use the word what? Identical. Okay? So you just have to divide by the product of the identical letters. So number one. Here, the first question says, in how many ways can you arrange the letters in the word cumulative? Okay, so I'm going to show you using this. Yes. In this sense, but the letters, so the words may not have any meaning. Okay? We'll use this formula here. It's part of the counting principle. Right, number one. Now, because we have got identical letters there, it means we are counting the letters twice. So this n factorial here it's also including the identical letters. So in that case now we have to divide by the product of the letters that are identical. Right? Then we can eliminate double counting. Okay, so number of says, in how many ways can you arrange that? Number of arrangements, number of ways, okay, let's call it number of ways. This will be equal to, now the word cumulative is for how many letters? It has got 10. So this will be 10 factorial divided by, now which letters are identical? Okay, we only have 2, so we divide by 2 factorial. What answer do you get? You get 841. Wait. You get 1,860,000. 1,814,000. 814,000. 800. 400. Okay. So these two here, it is the number of U's that are identical. Okay. Now in this case we only have one letter which has got an identical letter to it. So we just divide by its factorial. Okay. Now let's try number 3. This one here. Now, how many arrangements of the letters in the word standard deviation start and end in N? Okay? So, you have got the word standard deviation. Yes. Okay, so okay, first, if we are going to fix, okay, if we are going to fix the first position and the last position, okay, it's going to be what? Fixed. How many letters will be left? Okay, remember, he says The word standard deviation starts and ends in n. So we're going to have this n in this position, and then that n there will be at the beginning. How many letters will be left? So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? Oh, I'm sorry, it's not 16. I made a mistake. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? Remember, the beginning and the end must have an end. Okay? So we will end up having 1 times 15 factorial times 1. Then we need to divide by the identical letters.
Before we go, so these 1 times 1,
Those are the two ends.
and they use this right now. 1 times.
They are going to be useless now because they are fixed. So we're not going to worry about them. Right? Then
But you have to.
the other letters now, which ones are identical? Okay, we have got A, there are 3 A's. Okay, so we'll divide by 3 factorial times. Any other letter?
D.
D, we have got 2 of them. 3.
Find out the D.
Oh, we have 3. So that would be 3 factorial times. Any other letter?
So,
We have got T.
you've got
We have got T. There are 2 T's. So that would be 2 factorial.
So,
Yes?
what if, you have a question like this? The possibility of all 4
Okay. Can you
and 0.
no, you can't get a question like that for this kind of a question. Okay? Don't complicate things.
Okay, wait, so wait, isn't that 1 times supposed to be outside of the fractions because it's like the word and then 1.
Even if you put it outside, it won't make a difference.
Okay, but what's the right answer?
Okay, I prefer to write this way because what this means is the first letter is an N, the last letter is an N. How many are left between those 2 N's? 15. So 15 factorial.
But can't you put that outside of the fraction?
Even if you put it outside, it won't make a difference to the
But it's
final
going to be
answer.
right.
Okay, Kitano, you can do it the way you do it.
I'm saying, but it's going to be right.
It's the same thing. Okay, is there any other letter here besides those 3?
No.
Okay, can you simplify this for me?
So where do you get the 2 from the end?
Okay, there are 2 T's.
Ooh, and then there's
What answer do you get?
It's a 1 comma,
It's 1,8.
1,8 was 6.
Okay, let's just okay, let me write this. It is 1,1. I'm getting 162,144. 144.
I'll say it to the left.
And to the power. Very nice. Yes.
So,